Port stage pushed. Engine arm is S. Okay, I'm going to get the pro. 99, proceeded. 3, 2, 1. Ignition. Right away, Houston. Vector grid. Ag thought.
So what forces, what stresses and strains were on those astronauts as they, in that case, left the moon for the very last time? Well, that's where the concept of G-force is. It's a measure of stresses and strains on astronauts. It's a little bit misnamed because it's not strictly speaking the only force that's acting on an object. I want you to consider this astronaut here who's in orbit around the Earth. This astronaut would feel weightless. We'd actually say that their G-force, the number of G's that they're experiencing is zero. They feel completely weightless. Are they weightless? Is there no force acting on them? Well, of course, there is a force acting on them. There is their weight force. That is the force that's causing them to go in a circle. I'll draw it a little bit more accurately. Here's our astronaut here. Accurately, I'm not sure about that. Here's our astronaut here. He's going in a circular path around the Earth. Therefore, there has to be a force, a centripetal force. Remember, that was Newton's genius to realise that the centripetal force was being provided for by gravity. Okay, so it's not actually, the G-force isn't, we can't work it out by asking what forces are acting, or that force that's acting upon him. So what actually is G-force? Well, G-force might be better understood if we go back to the rockets that we launched last term, from our model rockets. Now imagine if we've got a small person and stuck that person in the rocket and they're on the launch pad. How many G's would they feel? Well, they'd feel 1 G. They'd feel the normal kind of forces that are on them because they're on the planet Earth. Well, what are the forces that give rise to that? Well, they have their weight force, which is mass times gravity, and they have the reaction force, which is going to be equal and opposite according to Newton's third law. It's going to be the reaction force, which of course is going to be mg as well, and so they're going to feel the normal kinds of stresses and strains. It's this force here, that's what the G-force is. If I take that away, like I did with our astronaut who was in free fall around the planet in orbit, he only feels one force, he doesn't actually feel any G-force. So the G-force is the forces that are kind of pushing on our body, compressing our body against the way that we want to go. Now I want you to imagine that we 5, 4, 3, 2, 1, we ignite our rocket and the rocket launches. So the rocket's now going to have some kind of acceleration, which means, so if the rocket is accelerating upwards, the size of this force actually has to increase because we want to now have a net force upwards. So here's our net force upwards. That's how fast we're accelerating. That's going to, the force on him, that extra force, is going to have to be ma, because F equals ma. In order to accelerate him with the rocket, he's going to have that size force on him. And this force here now, is, you can see, is not just mg anymore, it's mg plus ma. And remember, this is the G-force. That's how we measure G-force. It's how big this force is here. Okay, so if we put all that together, we can see that G-force is going to be mg plus ma. Now we want to compare that to what it would normally be like on Earth. Of course, we've evolved on Earth. We spend our time on Earth. We know what Earth feels like. So we're going to divide that by mass times what gravity normally is on Earth. And very quickly looking at that, you can see that all the m's cancel, and that gives us that G-force equals G plus A on 9.8. Of course, that G here is usually 9.8 if we're blasting off from Earth, but of course if we were blasting off as they were in the original clip from the Moon, this G here could be a lot smaller than 9.8. So G-force is really, if you like, it's the reaction force. It's the force pushing on our bodies from the rocket or from the seat that we're sitting in. And it's a measure of the kinds of stresses and strains that an astronaut might experience in liftoff or in re-entry.